the electric current is wrapped in a way. So, so what we have now, what we do is you point your thumb in the direction of north on the solenoid or electromagnet, because it's like it produces such a magnetic field that there's a north and a south end. Okay? So now we point in the direction of the north, okay, of the magnetic field.
I know which way.
I'll keep as I tell you the rule, you'll see. And like, because, okay, yeah, I'll tell you. So once you have the north, then if you have your fingers, you can see the direction of the electric current. So as you said, how do you know which way is north? If you know which way your electric current is going, so if you know that it's wrapping around this way, then your thumb is going that way, then you'll know it's north.
Wait, what?
If you know which way the electric current is going, you can determine, do you put your fingers this way or do you put your fingers this way? So depending on which way you put your fingers will determine which way your thumb points. And that will give you your north or south. And there's multiple ways to like, either you could be told which way the electrons are going, or you can look at your battery, right? If you can see the battery and see the negative positive, then you can know which way they're flowing, okay? Or you might be given the north-south and have to determine the electric one. So, pardon?
The current's going in the opposite direction as the thumb is.
Sorry, I don't know what it is. Okay, so if on the front of the solenoid, the current is going down this way, okay, wrapping around this way, then his thumb points that way, so then that way is north.
It's going the other way.
What's the other way?
The flow. The flow travels to the right.
What do you mean? Can you?
Look how the arrows are going. Like it starts at X and then it goes up and then around this way.
So X is going in, right?
Yep. Here. See, the current comes up and then it goes around till the end.
Yeah, it's right.
But his thumb's going, like it's going this way. His thumb's going that way.
His thumb shows the direction of the magnetic field.
Isn't the magnetic field the direction that
It's like the opposite of the first rule we learned. Are you getting mixed up with the first rule?
Maybe.
I just want to try and understand your question. I don't think that it's invalid. I just don't know.
Like, see this way, it goes this way, and his thumb is pointing that way.
Yes.
But this way, it's going this way, and his thumb is pointing that way.
Oh, I see. It's just if we took this wire and kept it going up one more, like if we kept wrapping it around, then it would show at that point, like that. And this one, if we wrapped it around once more, like then it would be the same.
But it doesn't matter which way the electrons are flowing.
No, it does. It matters. That's everything that matters. You're just looking. Maybe just don't focus on the dots and the X's for right now.
That's not though. It's like the arrows because
They're both going the same way. It's not whether they're going this way or this way. It's if they're going up or down.
I'm understanding this question more, but
Yeah,
It's-
I understand what
I
you're
think
saying.
you're thinking of the first rule, and you need to just forget about the first rule for right now.
Because
I just don't know what
Because
to
is
look
it the
for.
dot and the accent that are confusing you?
No.
no,
What is?
I
Yeah,
think
what's
that
confusing about the picture?
The way the electrons are flowing.
He's not following the way the electrons are flowing in that way.
but
Like the,
it is.
wait, which one's the dot and the X now?
I'll erase
No, no, that's not. I'm not looking at the dot in there. I'm just looking at the arrows.
But his fingers are following
How
the
do you-
way,
Yeah, but how do you know which way the electrons are flowing? It could be what Hayden's saying, since
So,
they're going that way, why
okay.
did they go to the dock?
because you would be given, say, the battery, and you would see, okay, this is the negative end, and it's gonna flow around this way. Like, it doesn't show the battery in this picture. But you won't be just expected to be like, look at that coil, which way are they going? You would be given more information. How about we do some examples? Let's do some examples before we you get overwhelmed.
I got it until I looked at it.
Okay, well, just don't. Okay, let's finish this, go through examples, and then it might clarify, and if it still doesn't, let's keep questioning. Okay, so let's just read here. Okay, so this is in your notes. So curl your fingers of your left hand in the direction of the electron flow. So it's the opposite of the first rule, pretty much. Keep your thumb straight. It will be pointing in the same direction. And this is where you write it in. As the North Pole of a compass would be if the compass was put there. Which way would that arrow be pointing? So, i.e. in the direction of the magnetic field lines inside the solenoid. So remember, the magnetic field is strong inside. So that's the direction we go. A word of caution when we talk about magnetic poles, we are referring to them being just outside the solenoid. Okay, so fill up your page. You need to know one direction first, just like the other ones, to be able to apply the second left-hand rule and determine the unknown. The left-hand rule, again, only works for the flow of electrons or negative charges. Use the right hand for positive. Okay, so if you ever told them.